2. We are starting coordinate geometry today. We will be covering distance formula. Let us first of all discuss what are coordinates. The axis, x-axis, this is y-axis. Let's say we have point P with coordinates alpha and beta. Alpha is called abscissa or the x coordinate, whereas beta is the ordinate, also called the y coordinate. And these are coordinates of point P. Alpha and beta are coordinates of point P. What is abscissa? Abscissa is distance of point from y-axis. So this distance is alpha. This is abscissa. And distance of point from x-axis, this is beta, the y coordinate. So coordinates are nothing but distances. These distances have convention. Alpha is positive when point P is to the right of y-axis. So when P lies to the right of y-axis. And to the right of y-axis we have first quadrant and the fourth quadrant. So that is in first quadrant and in fourth quadrant alpha is positive. So we have alpha greater than 0 here and alpha greater than 0 here. So with the same convention, alpha is negative when point is to the left of y-axis, that is in second quadrant and in third quadrant alpha is negative. Similarly, the ordinate beta is positive if the point lies above the x-axis. So beta is positive in first quadrant and also in second quadrant. So for these two quadrants, beta is positive. For third and fourth, beta is negative. So we can see if a point lies in the first quadrant, then alpha and beta both are positive. X coordinate and y coordinate are both positive. Alpha is negative here, beta is positive. Alpha negative, beta is also negative. Alpha is positive and beta is negative. So that means if a point is with coordinates 5, -7, so it must be in fourth quadrant. If it is -7, -3, this is point lying in the third quadrant. Let us discuss the distance formula. So if coordinates of a point are coordinates of 2 points are known, this is point A, x1, y1, and this is point B, this is with x2 and y2. So this is given, coordinates of 2 points are given, we have to find out this distance. Okay, so finding distance from coordinates of A and B, for that we use distance formula. Let us first of all derive the result. Draw perpendiculars to x-axis to y-axis. So A is with coordinates x1, y1, this distance is x1, and y1, this is y1. Similarly, for B, we have x2 and y2, this distance is x2 and this is y2. Let's draw this triangle. Let's say this is point C. This distance is x2, whereas this is x1. So this distance will be x2 minus x1. This is x2 minus x1. Similarly, this whole is y1 and this is y2, so this will be y1 minus y2. This distance is y1 minus y2. Now in triangle ABC, AB square is AC square plus BC square using Pythagoras theorem, and AC distance is y1 minus y2. So this is y1 minus y2 whole square, and this is x2 minus x1 whole square. Or AB can be written under root of x2 minus x1 whole square plus y1 minus y2 whole square is same as y2 minus y1 whole square. So let's write y2 minus y1 whole square. So this relation, this is distance form. Let's say we have point P, coordinates 2, minus 3, Q. This is with minus 4, 0. We can find out distance between points P and Q. Distance PQ, this is y2 minus y1 whole square plus x2 minus x1 whole square plus y2 minus y1 whole square under the. So this is 36, 3 square 9, and this is root of 45. This is distance PQ. Now read statement of question number 2. We are given points P and Q. Coordinates of P are x1, y1, Q is x2, y2. We have to find out distance PQ for two different cases. One, PQ is parallel to y-axis. Second, PQ is parallel to x-axis. Let's consider this case when PQ is parallel to y-axis. So we have P here, x1, y1, and Q. Let's say Q. This is x2, y2. This is line joining P and Q parallel to y-axis. This is first case. So we have to find out distance between points P and Q. So what is distance PQ equal to? PQ is, we know x2 minus x1 whole square plus y2 minus y1 whole square, then another. When PQ is parallel to y-axis, this means this distance, that is x1, is same as this distance, that is x2. So that means x1 and x2 are equal. Therefore, this will be 0. So PQ will be y2 minus y1 whole square another. This can be written mod of y2 minus y2. Similarly, when PQ is parallel to x-axis, so let's draw coordinate axis. X-axis, y-axis, this is origin. P is here x1, y1. This is Q, x2, y2. So we can see PQ is parallel to x-axis. Now in this case, this distance, that is y1. Distance from x-axis is the y coordinate. This is same as y2. So y1 is equal to y2, means y1 minus y2 or y2 minus y1, this will be 0. So in that case, distance PQ, that will be modulus of x2 minus x1. Okay, coming to the next one, we have to find out a point on x-axis which is equidistant from two given points with coordinates 7, 6 and 3, 4. We draw the axis. This is the origin. Let's show 7, 6. This is, let's say, A, 7, 6. 3, 4 is the second point. It's here, let's say. This is 3, 4. These are the 2 points. We have to find out third point which lies on the x-axis and which is equidistant from A and B. So that point will be somewhere here. Let's say it's here. And any point on x-axis, this will have its x coordinate, let us say it's alpha, but its y coordinate will be 0. Any point on x-axis has y coordinate equal to 0. Similarly, if we have point on y-axis, its x coordinate is 0. Now, according to the condition, this distance, this is same as this distance. So we apply the condition that PB is equal to PA. It's always better to apply this condition by squaring both sides. So what is PB square? It's alpha minus 3 whole square plus 0 minus 4 whole square, that is 16. Is alpha minus 7 whole square, 0 minus 6 whole square, that is 36. This is minus 6 alpha plus 9 plus 16. This is minus 14 alpha plus this is 49 and plus 36. We can cancel out alpha square, shift this to this side. It's 8 alpha. This is 85 minus 25. That is, this is 60. Or alpha is so we can say the required point is with coordinates 10/3, 0. This is the point. Okay, let's discuss this one. We are given a quadrilateral with vertices 4, -1, 6, 0. Next point is 7, 2, and the fourth one is 5, 1. We have to prove that it's a rhombus. Then further we have to check if it's a square. So let's draw. This is first point, this is second, this is the third one, and this is 5, 1, the fourth point. These are vertices of a rhombus. So rhombus has all the sides equal. To find out distance AB, distance AB is 6 minus 4 whole square. Now let's find out AB square. This will be 4 and plus 1. This is 5. Distance BC or BC square. This is 1 square plus 2 square. This is 5. Then CD square. This will be 2 square 4 plus 1. This is also 5. And we find out distance AD square. This is 1 square plus 2 square 4. This is 5. So this proves all the sides are equal. So that means it's a rhombus. What is the difference between rhombus and square? Square has also all the sides are equal sides. But in case of rhombus, the length of diagonals, that will be different. So if it's a square, then AC and BD are equal distances. But if AC and BD are different, then it's a rhombus only, not a square. Find out distance AC. AC square, this is 7 minus 4, 3 square 9 plus 9, this is 18. Next we find out BD square, this is 1 square plus 1 square, this is 2. Since these are different, therefore this is not a square but rhombus only. Before we solve the next one, there is a formula in trigonometry. This is cosine formula. So for any triangle. This is not necessarily a right angle triangle. This is BC length we represent with small a, AC with small b, and this with small c. And if I am to find out cos of angle B, the formula is a square plus c square, or let's write c square plus a square minus b square upon 2 times this product, 2 times c. This is called cosine formula. So here we have vertices. This is, let's say, A, B and C, 1, 1. This is 4, 5. This is 6, 13. We have to find out cos of this angle. Let's find out distance BC and represent by small a. This is small c and small b. So distance BC square or a square, this will be 6 minus 4. This is 2 square, that is 4. Then 8 square, 3 minus 5, 8 square, that is 64. So 68. AB square or C square, this is 3 square, 9, 4 square, 16. This is 25. And also AC square or B square, this is 25 plus 144. This is 169. So what is cos of A? Cos of angle A is this square plus this square. C square is 25 and plus B square. B square is 169 minus A square. A square is 68 upon 2 times this into this. C is square root of 25 into B. B is square root of 169, that is 13. So this will be 101. This is plus 25. 126 upon 2 into this is 5 into this is root of 169. That's 13. This will be 63 upon 65. This is how we find out cos of A. So I repeat cosine formula. We use cosine formula to find out cos of any angle of a triangle if all the 3 sides are known. For example, if I am to find out cos of B, it's this square plus this square, C square plus A square minus side opposite to this B square upon twice the product of C and A. This is cosine formula. Next, we have to find out coordinates of circumcenter of a triangle. The 3 vertices of triangle are given, and after circumcenter we have to find out the circumradius. Let's draw the triangle, the semi-triangle. This is 8, 6, the first point. This is second one is 8 minus 2. This is 2, minus 2. Let's find out distances. Okay, first of all, let us understand what is circumcenter. Circumcenter of triangle will be center of the circumscribing circle. This is circumcircle. That is circumscribing circle. This is center. Let's say this is O, alpha, beta. So can we say distance of all the 3 vertices of triangle from center will be the same? This is, the 3 distances are equal. So this is exactly what we use to find out circumcenter. We assume circumcenter is alpha, beta. Then we know OA is equal to OB is equal to OC. There are two unknowns. We write two equations. OA square equal to OB square and OB square is equal to OC square. And we then solve these equations simultaneously. And we'll get alpha and beta. Let's see how to solve. OA square, this will be alpha minus 8 whole square plus beta minus 6 whole square. This is equal to OB square. Alpha minus 8 whole square plus beta plus 2 whole square. So we can cancel out this term. We have beta square minus 12 beta plus 36 is beta square plus 4 beta plus 2 square 4. This will cancel out. 32 is 16 beta or beta is 2. OB square equal to OC square is alpha minus beta whole square plus beta plus 2 whole square. This is alpha minus 2 whole square plus beta plus 2 whole square. Here this term will cancel out. We will have, this is alpha minus 8 whole square. We will have alpha square minus 16 alpha plus 64 minus 4 alpha plus 4. This is 60 and this is equal to 12 alpha, or alpha is 5. So this is alpha, this is beta. So what is our circumcenter? Circumcenter is alpha comma beta, that's 5 comma 2. And what about circumradius? Circumradius is this distance, also this distance or this distance. So let's find out distance between points O and A. Let's find out first of all OA square. This will be 8 minus 5, 3 square, that's 9. This is 4 square, 16. That's 25, or the circumradius is 5 units. The next one, we are given points A and B, coordinates in terms of T1 and T2 parameters. We have to find out distance between points A and B. So from coordinates we can find out distance using the distance formula. So write distance AB square. This will be this minus this. 81 square minus 82 square x2 minus x1 whole square plus this y2 minus y1 whole square. We can take a common, so it will be a square. T1 square minus T2 square is T1 plus T2 into T1 minus T2. Whole square means square of this, square of this. From the second term we take 2a common, so outside it will be 4a square, inside T1 minus T2 whole square. We take a square into T1 minus T2 whole square common, and inside it's T1 plus T2 whole square plus 4, or AB is A into T1 minus T2 into square root of this expression.